Here now the focus is on network core. What is the purpose of network core? I think now all of you at least have an overall understanding of the network core. It is important for providing connectivity services, and how exactly the network core provides the connectivity services is through the establishment of connections from source to destination. Network core mainly comprises of the network supported and managed by the internet service providers, and their main job is to reroute the packets, is to switch the packets from one interface to the other interface so that it can finally reaches the destination. Now there are two ways of doing it. One way is circuit switching, and another way is packet switching. In internet, for data communication and for any sort of a communication which goes over internet, it uses the concept of packet switching. Whereas in normal telephonic networks, there still they use the circuit switching concept, though they are also moving towards packet switching. But still, that circuit switching, the traditional way, they opt for instead of packet switching. Now, what is so fascinating about the packet switching that internet uses it instead of using circuit switching? So there we have to go in detail about circuit switching and then its limitations, and then we will finally discuss about the packet switching. In circuit switching, if you will see, first here in this diagram, you can see what is network core. Several times even I have explained it to that network core is nothing but to the networks managed through internet service providers. So these big organizations maintain these networks. They put in a sort of an investment for setting up infrastructure, and then they connect themselves all together so as to provide seamless end-to-end connectivity. So here in this in these bold lines you can see that is all the part of infrastructure or network core network. So here, if just for an example, if you have to understand what is circuit switching, so same example we will use. So here there is a system, and this system wants to have an access to one of the server here in the enterprise network. Enterprise is maintaining a website over this server, and this system want to have an access to this server. Now, if we will use the concept of circuit switching, so initially, because here there is no option, it has to contact the cellular tower. And with cellular tower also there is no option, it has to redirect the packet to the edge router. So it will come here. Now it will direct it towards its provider, internet service provider. But here, if you can see, it has several options. It can reroute the packet towards this router. It can reroute it towards this. It can directly reroute towards this edge router. So it has several choices. Now, based on switching, initially we are considering the switching concept. So based on switching, so suppose if we are assuming, though in internet it's not going to use the circuit switching, but we are assuming that right now it is using the circuit switching concept. So in case of circuit switching, before transmitting data, before transmitting data packets, it has to establish the network, the complete network has to establish a path comprises of links and the nodes which comes in between towards the destination. So there must be a particular circuit which engage source node to the destination nodes, and in between comes there several links, several other router nodes. So but it has to be fixed initially. So that is also termed as a resource allocation. So resource must be allocated initially, and that phase is called, so in circuit switching there are three phases. First one is connection setup phase, establishment phase. So initially when this node has to start transmitting its data towards the destination, it wants to engage with the server destination. So initially it will not straightway start with the data. It will request for the connection setup. And this node will request here, this node will request here. So requesting means all all the nodes which are accepting the request, they have to maintain a sort of a state which will eventually maintain the circuit starting from source to destination. And whenever after this phase is over and the source node comes to know through some acknowledgement packets that now setup phase has been over, then it will start with its transmission of data. So the data will start from source, will reaches the destination, and all the packets, all the data part, whatever source will share with the destination will find its path through through that established circuit from source to destination. All the packets will go. So suppose here comes this node, then this node, it will finally transmit here, then here, then here, then here, here, and finally to this destination server node. So all the packets which will start generating from this source node will eventually leads to the destination through this established path. So there will be no deviation. The good part is that though you will spend some time in establishing the connection, but once you have established the connection, then all the packets will go. So there, whenever you will send, you can send in sequence, so you don't have to maintain a sequence explicitly either on the source node or on the destination nodes, because in sequence when you will send it, so destination can also find the packets in sequence. It doesn't have to reassemble it. Quality of service parameters will also increase. Obviously later on delay will be less because there will be no congestion, because already you have allocated resources, dedicated routers are there for rerouting your packets. So they have allocated their buffers for you, they have allocated the links for you. So everything they have done it prior to sending your packets. So that is good part in circuit switching. But the limitation and the drawback is that once you have established the circuit, no one can use it apart from you. So suppose if you are using it for data communication, then problem is that you are not generating data at a constant rate. Sometime you want to access that server, sometimes you don't want to access that server. You don't want to use those allocated resources at all. In that situation, I think it is not efficient to use in case where the traffic is bursty in nature. Sometimes it is more, sometimes it is less. And you can't reallocate the established setup path to someone else to use it at the time when it is going idle. So that is the drawback in case of circuit switching. How you can do the circuit switching? So obviously, suppose from here to here, it's a link. It may be any telephonic wire, it may be any coaxial cable, it may be any air medium, wireless medium. It can be any link. So obviously, The whole link you can't give. Then you suppose if there is a frequency band it can support, suppose from 0 to x megahertz, it can support, this link can support, and you require to transmit the data x by 4 bandwidth. So in that situation, there's a possibility that this link you can share amongst 4 users. So you can allocate at a time this link to 4 users, then you are dividing this link into 4 channels. 4 channels. So from here to here at a time, 4 users can have an access over this link, but in different frequency ranges. So when they will start transmitting data for different users, this node has to modulate signals on different frequency ranges. So different channels you have to create, and every node can share the link capacity amongst different users based on the bandwidth link supports. So that is called circuit switching, and there are two ways of doing it. One way is you can divide the frequency, which I have explained right now. That is called frequency division multiplexing. From here, this node to this node, there is a one link with support a one frequency bandwidth, and you can divide that bandwidth into 4 or 5 parts depending on the requirement your users depending on your users requirement. You can divide it. So that is one. Another one is that if suppose this link is need to be shared amongst 4 users, you can divide it in terms of time to access the link. That is called time division multiplexing. So in round robin way, at this router, it will gain access to all the data which it has to send from 4 users. So here suppose 1, 2, 3, 4, 4 users are there. It has all the data which it has to send from all the users. They have shared it to cellular tower, and cellular tower has given it to this router. So this router will store all these things somewhere in its buffer, and it knows it that this data belongs to this user, this data belongs to this user. Suppose these are A, B, C, D users. So it knows it that this data belongs to A, this data belongs to B, this data belongs to C. And then it has to share the capacity of this link amongst these 4. So how it will do, it will make one packet, uh, and in that packet it will divide the time slot. So for, like, suppose if for the time duration in which it is generating the packet is 4 milliseconds, so in for 1 millisecond it will give an access to A's data, another millisecond it will give an access to B's data, then C's data, then D's data, and will make one packet and then will transmit it. This node also knows it. Then it will take out the data corresponding to nodes A, B, C, D, and then keep and store them in its buffer and then reroute it accordingly. So that is the concept in time division multiplexing, where you are using the same frequency bandwidth. So you are giving an access to the same bandwidth which link is providing to you, but you are channelizing it in terms of dividing it in terms of time. Whereas in frequency division multiplexing, you have divided in terms of frequency bandwidth itself. So here there is a catch. In frequency division multiplexing, the bottleneck will be bandwidth. The link has a capacity, but you have divided that capacity. And though they can share it for infinite time, but they will always get less bandwidth. So any application which is bandwidth specific and it requires more bandwidth, then those applications I think will be hard to yes, those applications will find their time hard on these kind of networks where you are using frequency division multiplexing. Whereas in case of time division multiplexing, it's good where the traffic is bursty. Sometime you are using it, sometime you are not using it. But the problem is that it many times, so your time slot may go empty. You don't have any data to send at that time, and that time slot other nodes can't have an access to. So that is another drawback concerning time division multiplexing. So these are the two ways through which we can implement circuit switching concept. Now we'll come to packet switching implementation. That what is packet switching implementation? In packet switching implementation, there is no connection setup phase. Yeah, one more thing I want to remind you that there is in circuit switching, initially the setup phase is there, then data transfer. Once data transfer will be over, then there is a connection breakaway phase. Then all the resources which has been allocated for that circuit has to be given away back to the network for its reusing purpose. So connection setup phase, then transfer phase, data transfer phase, and then breakdown phase, connection breakdown. So that is all about circuit switching. Now we will move to packet switching. That what is so specific in packet switching? Why in internet we are using packet switching? Already we have seen in circuit switching, if the traffic is bursty in nature, it's not an efficient way to go and have a connection establishment phase and keep it forever till the time you are transferring the data, though you are generating traffic intermittently. So you're not effectively utilizing the network. So in order to effectively utilize the network, what can we do? At the time when we are generating the data at the application layer, so here in packet switching, we will divide the data into different chunks. Those are called packets. And what these switches will do, they will consider all these packets independently. Though from the same application, there may be 100 packets on any switch or any router in the infrastructure or the network core, but all packets are independent for that router. That router will independently process all the packets. There is no correlation that router will set up. Router will independently look at all the packets which come across on its interfaces. So here at the application layer, data being generated, what transport layer will do, transport layer will chunk it out and create a segment. We'll add certain control information because here you are breaking down the data packets, but at the application layer, at destination node, there it really requires it to reassemble. So there must be some sort of sequencing parameters, so sequence numbers which you have to maintain. So all these things are called control informations. So at the destination node, application layer should know in what order the received packet should be sequenced so as to process it, because until and unless you will sequence it, your application at the destination node will not be able to process it. That is one challenge. So all these challenges being addressed through control informations. Another challenge is it may be possible that at the destination node, destination receives several packets, and there are several applications, internet applications running on that system. Now, how the destination node will come to know that this packet belongs to this application? That also been taken care through port numbers, through port addressing. So through port addressing, because every application has a specific port number, that control information also we add in header field at the transport layer, and then we will pass it on, so that whatever the required control information destination node require, all those information at the source node we will keep along with the data, and that thing at the transport layer is called segment. That segment at the source node being passed on to the network layer. Network layer provides certain services to the transport layer, and the service is the routing information. So regarding routing, so that intermediate nodes can come to know that this packet requires to be destined towards this node. So what is the destination node? Every intermediate node will figure it out only through the control information which at the source node network layer will add to the segment received from the transport layer. Then that is called network packet. Then finally it will transfer it to data link layer. You know it, data link layer is used for hop to hop transfer. Then at the physical layer, every bit will find its course in terms of electromagnetic signals, and which reach to the next hop. Then next hop will do the reverse of it, will convert your signals to bits, and then after finding out frames in terms of bit, will a node will reprocess it, then will pass it on to the network layer. Network layer will reprocess it. Reprocessing means you require certain codes to process it, and there you will find out that what is the destination node. Based on the destination node, the network layer will consult the forwarding table and reroute it towards the destination, and the same way everything will be repeated. And finally the packet reaches at the destination node. So that is the concept of packet switching. So it may be possible that suppose at the application layer, regarding that data which being generated through application, and there you create 100 segments, and those 100 segments will include the control information. And if there is an application and there are several segments which all belong to the same application, they all have the same control information, except the sequencing information. The sequence number will definitely change. So every segment has a sequence number. Everything once will start with the transport layer, and its operation will come to know that how all these things happens, how the sequencing happens, how segmentation happens, what are all other control informations apart from the port number, which transport layer adds at the transport layer and provide those kind of services to the application layer. What is the minimum information which we do require to write as a control information at the transport layer? Everything will come to know once we'll understand TCP and UDP protocol, which works at the transport layer. So that is the concept behind packet switching. So in packet switching, first at the application layer, data being generated, then at the transport layer, you divide it into different chunks. You will not send the entire data all at once. You will divide it into chunks. You will then add control information, and then you start it to for routing purposes. So intermediate nodes will consider every individual packet as individual. There will be no correlation with other packets that node has sent this packet to here, so it will redirect all the packets along. It has no business to deal with the control information being added at the source node at transport layer and application layer. It will only process the network control information, what the node has written, the source node has written at the network layer, and the network layer, it has added source address, source IP address, and destination IP address, along with other informations too. But those are two are important. Based on these important informations, intermediate nodes will reroute the packet so that it can finally reach the destination node. And at the destination node, because it is an AND node, so obviously there you have to run the application, the process. So it will process the transport information as well as the application information, control information. So here there's one example. So suppose here in this example, there is a source node and there is a single intermediate node in between source and destination. There are 3 packets, and each packet comprises of L number of bits, and the transmission speed from source to destination, source over this link is R bits per second, and over this link also it is R bits per second. R bits per second means source can generate electromagnetic signals at the rate which can support the transmission of R number of bits per second. In other way, at the source, at the data link layer, every packet comprises of L number of bits. So it has to push L number of bits over the wire. Over the wire, it is electromagnetic signal. It is not in the bit form. So it is in the analog form. So your source has to convert bits or the digital form into analog form. So at what rate your source is doing it? It is doing at the rate which support the transmission of R number of bits per second. So if the packet comprises of L number of bits, how long will it take for a source to generate that many signals which would have transmitted L number of bits? So that will be L by R, because in 1 second, so here you can see L is the size of packet and R is R bits per second. Bits per second. So in 1 second, 1 bit require how many seconds? So if you have to calculate for 1 bit, it is 1 by R, because R bits per second, in 1 second R bits. So for 1 bit, it is 1 divided by R. Then for L number of bits, it will L by R. Okay. Oh, it's simple arithmetic calculation. Then next we'll see there are 3 packets here. And here all the routers will use store, carry and forward mechanism. What is store, carry and forward mechanism? So there are 2 possibilities. One, source will start sending the data. So we are focusing on the first packet. So first packet has L number of bits. So source will start generating electromagnetic signals corresponding to L number of bits. So suppose for the first bit, it has, we are considering in one signal corresponds to 1 bit transmission. So it has to generate L number of electromagnetic signals. So for first packet, so it will start generating the electromagnetic signals corresponding to the first bit. So it is up on the wire, first signal is up on the wire, then it will create a signal for second, then third, then fourth, till it will create the signal, it will generate the signal for L number. So once it will create a signal for first bit, so first bit will reach here first, second bit will reach second, third bit will reach third, corresponding electro signals will reach here. So there are 2 possibilities that this router can retransmit it. The moment first bit will reaches here, it will start retransmitting it. Then once the second will come, it will retransmit it, it will third retransmit it. So there will be no buffer delay. There will be no wait. but it is not so. Why is it not so? Because this node has to process the packet. Until and unless it will not process it, it will not be able to figure out what is the destination node. And till the time it will not be able to figure out what is the destination node, it will not reroute it, because it will not be able to consult its forwarding table. And unless it will consult its forwarding table, it can't reroute it to other interfaces, the destined interfaces. So for that purpose, it has to first store it. It will keep waiting till all the L number of bit signal reaches the intermediate node. Once everything will be reached, then it will process it. So processing will also take time. Once it will process it, then it will figure out that this is the destination node, and then it will reroute it towards the particular destination. So that is called the store, carry, and forward mechanism. So first it will store, it will carry it for a while till the time that packet reaches, packet will find the processing time. Then once the processor will start processing it, then it will reroute it. So here also it will require the packet to come here till the destination L by R seconds. So first packet will reaches here after 2L by R seconds. Then second packet will reach at 3L by R. Third packet which will reach here at 4L by R. So this is normal arithmetic calculations. I think you would have understood this. Now we will generalize it. Suppose instead of one router, if there would be n minus 1 routers in between, n minus 1 routers. So if there is one router here, there are two links. If one router is there, there are two links, and two links corresponding to 2L by R delay for single packet. So if there would be n minus 1 routers, there will be n number of links, and each link would require L by R second for its transmission, and there are n number of links. So the generic formula for the delay, the transmission delay, where there are n minus 1 intermediate router, is n L by R. N L by R. So this is the end-to-end delay. Here we have considered only the transmission delay. There are other types of delays as well. And what are all other types of delays? So here itself I want to mention. One is transmission delay. I've explained it. If you have any query, you can ask me again. And the second one is propagation delay. The propagation delay depends on the distance from one node to another node. Here, this link supports R number of bits per second. So the signals which you would generate, those generation of the signal can hold the information regarding R number of bits per second. So that is called the transmission speed. Second one is propagation speed. Once a bit is on wire in terms of its signal, then obviously it will start propagating. It will start propagating and finally reaches the destination. So the propagation requires certain time. There is a propagation lag, there is a propagation delay. And that delay, how we will calculate that delay depends on the speed of electromagnetic waves in that material. So here, if it is a copper wire, electromagnetic signals based on its frequency may have different speeds, but as a general rule, we'll consider it as a light speed, 3 into 10 raised to the power 8. And if ever we'll ask any question, we'll provide the transmission speed. And if it is not there, you can always use the light speed, 3 into 10 raised to the power 8 meter per second. So suppose if the distance is d and the speed of that signal is c, then d by c will be the delay, propagation delay. So one delay from here to here is transmission delay. That is the time lag in creating the electromagnetic signals. So the source will start creating the electromagnetic signals, and based on the capacity of the link, because capacity of the link means it can sustain how many number of electromagnetic signals at a time. That is that in terms of the capacity you can understand. So based on the capacity of a signal, you can generate the electromagnetic signals for transferring your bits, transferring your digital data. So how long it is taking for you to generating those signals, that attributes, that accounts for the transmission delay. And once your signal is up on the wire, how long that signal will reaches the destination or the intermediate, whatever the next node is. So that is called the propagation delay. Once it will reaches here, once your packet reaches here, all L bits reaches here, it has to wait here for a while. That wait time is called the buffer time, or that is called the queuing delay. Because as soon as your packet reaches the intermediate node, at the same time, it may be possible your processor is not free to take the packet for processing. It has to wait for a while. So in this way, there you have to maintain a buffer, and obviously that buffer will be limited, and that buffer will hold it for a while, and that time for which it will hold it is called the queuing delay. That is another type of delay. So, and finally, it will find the processing through processor. So processor will also take certain time. So that is called the processing delay. So in between, when you are sending from source to destination, there are four types of delays. Possibilities are, first one is the transmission delay, second one is the propagation delay, then finally it has to wait for a while, that is called the queuing delay, and then eventually it will be processed, that is called the processing delay. And once again the same cycle repeats. Once again this intermediate node has to retransmit it, so that is the retransmission, means transmission delay. Then the signal will propagate, propagation delay, finally it reaches there, then the queuing delay, then processing delay. So there are possibilities that if in between n number of routers are there, then you have to club it all together, you have to aggregate all the delays, and then you have to multiply it with the number of routers in between. That will give you the total delay, the total capacity. Once again, we will revisit it through certain numericals. Till that time, I think it is enough for you to understand that what is delay and what goes into delay, what amounts for propagation delay, what amounts for transmission delay, queuing delay, and processing delay. So that is all about delays. Packet losses. This is also important to understand. So suppose there is an intermediate router. It has three interfaces. One is outgoing interfaces and two are incoming interfaces. And the incoming interfaces links can support 10 Mbps. So these two devices can generate electromagnetic signals which can carry a capacity of 10 megabytes per second. So that many signals they can generate. So that many bits can be there over a wire in terms of analog signals, electromagnetic waves. So once it will reach the intermediate node, it has only one outgoing interface, and where it can retransmit it at a speed of 1.5 Mbps. So obviously there's a difference, and it's a massive difference. It can it is accepting it if we are assuming that A and B both are sending at 10 Mbps. So then it is accepting at 20 Mbps. So in 1 second, it has accepted 20 megabits, but it could have only sent out on its outgoing interface with a speed of 1.5 Mbps. So there is a lag, obviously 20 minus 1.5, that is 18.5 megabits per second accumulation in 1 second itself. So where that accumulation will find its place, that accumulated things will be somewhere in queues, that is also called buffer. So this node has to maintain that buffer. Once it will start maintaining that buffer, obviously buffer has a limited capacity, and that capacity can exceed. So once the accumulation will exceed the capacity, the accumulated packet size will exceed the capacity, then it will start losing the packet, because the intermediate node can't hold it. That is called packet loss. So that is one of the reason for packet loss, and this is also termed as congestion. So here this node is congested. It is accepting more, but it is not sending more. So that's why whenever the designer designs the network, they always keep in mind this interface capacities. And if there is a lag, what will be the proper queue size so that delays will be less. That's all regarding packet switching and circuit switching. Hope you would have understood all these things. If there is any query, you can ask me. In the next lecture, we will, in the next thing, we will understand about the design of the complete internet, the network of networks. So